Hello. How are we today?
I'm good. I don't know where Hassan is.
Still waiting for Hassan.
I'm sure he'll be here soon. I know he wanted to go over on that. Oh, there he is.
Okay.
Hi, Professor.
Hey, Hassan, how are you?
Good.
That's good to hear. What would we like to go over today?
I don't know if Melanie has anything in specific, but okay, so I don't really have like a test question or anything. I just want to for where is it? Ozonolysis. I think that's the name of the mechanism. I don't know if I'm pronouncing it wrong.
Ozonolysis, yeah. Mm-hmm.
Yeah, that one's confusing me because of all the different steps and stuff.
You're not
Could,
responsible for the steps. You're responsible for being able to predict the products. So we could do a sample problem for that. We'll
yeah,
do a
can we do one of those?
sure. Let's do a couple. Moving on over to here, and we're looking at ozonolysis. That's using ozone to cut a molecule apart. And it's an alkene molecule, although it's more general than that. We don't need to know that. We just need to know if we have a double bond. And say this double bond has these groups. And the first step, we treat it with ozone, O3, and step 2, dimethyl sulfide, which you'll see many ways. One way is to just show that. The question here would be to predict the product or products. So we got a product prediction box. You don't have to predict what happens to the sulfur, but for those that are curious, it still has 2 methyls and it has the third oxygen. So let's pretend that's a test question, and we'll put the answer down here. Okay, and the nice thing about ozonolysis is you just have to cut your double bond in half, and you keep both bonds, the sigma and the pi, but now they're both to oxygen. So on the top 2 carbons, you've got a double bond, but now it's to oxygen. And a second product, the bottom carbons, 5 of them, are double bonded to oxygen as well. And we have a methyl and then a propyl. 2, 3, 4. And I guess that, yeah, 1, 2, 3, 4, 5. And yeah, there's that. And also, oh, okay, let's go put that on another page. And here it is. Just change up our molecule. So maybe our new molecule, it's got other stuff going on. Maybe it's got a ring down here. It's got a double bond there too. And there's 2 double bonds. So here on the test, I would try to remind you, I want you to react every double bond you see. XS is the short form for the word in excess, or the word excess, but which means ozone is in excess. So we're going to react both pi bonds and follow the same pattern we did before. And let's just see what happened previously. When we had a carbon that had a methyl on one side and a hydrogen on the other, we got an aldehyde. Sometimes you get aldehydes. And the carbon underneath it had a carbon on each side. And when that's the case, you get a ketone. And those are the 2 things you can get. Well, there's a third thing. You know, it's a very specific example in the textbook. I'll put it as an aside down here. If you had this thing that had a carbon that had 2 double bonds. Oh, can't have an oxygen there already. And say it went like this. And we did the ozone. And we did the sulfur with 2 methyls. Sometimes it shows like that. What are you going to get there? You're going to get, let's see. You're going to get a double bond to the left to oxygen. And on the far right, double bond oxygen. Both pi bonds reacting. What happened to the carbon in the middle? That's the question. It didn't become an aldehyde or a ketone. Here we have an aldehyde. Here we have a ketone. And in the middle, we have a carbon that got a double bond to oxygen on the left and a double bond to oxygen on the right because each pi bond reacted. We had excess, so we made sure we reacted both pi bonds. And the carbon in the middle is carbon dioxide. So you got 3 products here. And let's do our molecule here now. We're gonna do a cut here. We had a question first.
Yeah. So for the other one, can you just go back to it? I just want to ask you a question about it.
The one down on the bottom.
Yeah. So for like this one, you basically just break the double bonds apart.
Yep, both of them. Yeah, and you get a oxygen on each side of that squiggle.
Okay.
Get an oxygen on the right and oxygen on the left, 2 separate molecules. Boom.
And then since the carbon's still in the middle and it has, let's say since it has the squiggles on like either side.
Yeah, because it's got a pi on either side. Yeah.
Yeah. So then you would add the oxygen. That's why there's oxygens and that's why you get CO2. Right.
Yep.
Okay. So basically you just like wherever there's a double bond, you break that off.
You break that and get an oxygen here and an oxygen there.
Okay.
And the third oxygen goes there, but we don't care. I mean, we care, but we don't get points for caring. All right, now up here, you're going to get C double bond to O. Sorry, C single bond to C with a double bond to O. And I don't think, well, make my box taller. Down here, that carbon also has a double bond to O. The ring is not intact anymore because over here, the ring broke right there. And the carbon over here went down to a carbon that has a double bond to O. It's not a separate molecule, but they're no longer connected to each other though down there. And that's what we have right there. We got ketone on top, aldehyde up here, aldehyde there, another aldehyde there. And there's in a nutshell, that's your ozonolysis there. We'll save this in a good location.
Okay.
And then we'll come back to more fun. Just making sure I save it in a good spot. There we go. And you think of some good ideas for when we come back, and we'll talk about those. Unless you have a good idea right now.
No, could we just do it when we come back? But okay, so let me just go over this with you one more time. I just want to make sure I get this right.
Oh, sure.
So the double bonds are always broken during ozonolysis.
Yeah, we break ozonolysis. We're not going to test your pronunciation, so no worries there. Yep, we break them in half. Yeah.
And then each like the end of each double, like the double bond.
Each carbon that participated in the double bond from carbon to carbon is now a carbon double bonded to a new oxygen.
Okay, and then if there was something between the double bond, right? Like with the previous example, then you would put a carbon on, oxygen double bonded to each side.
Well, just treat each side as a separate problem, and it's the same every time. This pi bond has to break. You get a double bond to oxygen on the left for this carbon, and then it's a new problem. Start on the right. You cut it there, you get a new double bond oxygen on the right. So there you go. So just don't treat it like it's a different thing here at all. It's always the same. Every time you see an alkene, cut it, carbonyl on each side of the former alkene.
Okay.
All righty. All right. So we'll be back very shortly, and I'll see you then.